So a full spectrum of sunlight is given below. Okay, if you refer to the figure below, we have three parts here: UV, visible, and infrared. UV sunlight is come from the light from the sun at the outer hemisphere. So we have UVA, UVB, and UVC. So 99% of the UV light is blocked or sustained by the ozone layer. And then this part is a visible light. Visible light means we can see the light from our naked eye. So this visible light, we have three color here, which is at upper hemisphere. So at the upper hemisphere, the visible light, the power or the spectral irradiance, which is in watt per square meter per nanometer from the solar irradiance per square meter, which is for the upper hemisphere, which is until 2 watt per square meter. But at the sea level, it become lower, which is below 1.5 watt per square meter. Okay, so this is the spectrum. So for this UV and visible light, okay, the wavelength until about near to 750 nanometer. This is very small. Okay, what about infrared? What is the infrared light? Can we see this infrared light? Boleh nampak ke tak boleh nampak?
Cannot.
We cannot see this infrared light because this is the red light. It's too bright. We cannot see with our naked eye. So the wavelength of this infrared light is between 750 until 2500 nanometer. Okay. So what is this? Wavelength at which photon energy equals silicon band gap. Okay, where does this photon come from? Photon ni dari mana?
Sun.
Okay, so from the sun, so the energy we call photon. So photon will knock the electron. So the electron will release from the atom, and then this electron will flow back to the hole. Remember back the concept of the PN junction that you learn in electronics, right? And semiconductor. Okay, ingat balik the operation of the PN junction from electron and then flow back to the holes. So what is the wavelength at which photon energy equals silicon band gap, which is about 1100 nanometer with nanometer, the wavelength. So the higher the number of wavelength of the irradiance, the lower the power, which is lower the spectral irradiance. Okay, you must remember that irradiance is actually power. Okay, any question about solar spectrum?
No, madam.
Okay. Next one, we go to figure sensitivity of PV cells with sunlight wavelength. Okay. So here we have various type of the solar PV module. For example, here the blue color is MCSI. MC stand for multicrystalline. SI stand for SI ni apa ni? Dalam periodic table.
Silicon.
Silicon. So this is multicrystalline silicon. So this multicrystalline silicon PV module will cover the wavelength of the spectrum from about 200 nanometer until about 1200 nanometer. Okay, what about this one? The green color. Okay, ini apa ni? What type of PV module for this one? Apa tu? Apa dia?
Triple junction kan?
This one is triple junction
G.
germanium, Ge. Okay, but this triple junction germanium, it cover for wavelength between berapa tu? About 800 until 1800 nanometer. Okay. So for this triple junction germanium, is it suitable for the outer atmosphere? Sesuai ke tak sesuai? Tengok balik. Dia dekat sini kan, kalau UV light ni, the wavelength between 0 to about 300, right? Okay, tak sesuai. Okay. So the highest efficiency of the PV module is multicrystalline or also germanium, but germanium is not really constant, and also the manufacturing of this triple junction germanium is quite expensive. So most widely used for PV module, we use silicon. Example here is multicrystalline silicon. Okay, what about this one? The orange one, What is ASI? Ni yang ni Apa benda tu? Ni macam kimia balik repeat back. You learn kimia, chemistry in your diploma, right? Okay. A stand for amorphous silicon. Okay, amorphous silicon is actually a family of the thin film. Amorphous silicon, thin film. What about CIGS? Okay, CIGS apa? Boleh Google.
Copper, indium,
Copper, indium, gallium,
selenide.
selenide. So this one also thin film, family of thin film, similar to amorphous silicon, Okay, another one. Satu lagi ni color hijau pekat ni.
Cadmium telluride.
Okay, this one is cadmium telluride, and the SSC
DSSC.
Dysynthesized
solar cell.
Dysynthesized solar cell. Okay, all of this is a family of thin film. So thin film well known because the efficiency is quite low. But if you want to produce more power, you need a more space. More space to produce similar power with the multicrystalline. So kamu tengok all the power is quite low for the thin film. Okay. We proceed to number 2, Earth Sun geometry. Okay, term used to describe any location on the surface of the Earth. Latitude is a geographic coordinate that specifies the north-south position of a point on the Earth's surface. Latitude is an angle which range from 0 degree at the equator to 90 degree to the north or south at the poles. Okay, that one is latitude. Longitude is also geographic coordinate that specify the east-west position of a point on the Earth's surface of the prime meridian at Greenwich Meridian, GM. Tak ada close bracket kat sini. Tertinggal. It is an angular measurement expressed in degree. Okay, let's say you have this GPS address. So this GPS address represent which one first? Latitude or longitude?
Latitude.
Okay, GPS address we have two concept, decimal concept and also latitude and longitude concept. Okay, it will present first by the latitude, okay, whether it's a north or south, and then represent by longitude, which is whether it's in east or west position. So example in this figure, so this is the latitude macam ni, latitude, and this is the longitude. Okay, how to remember this? Sekejap saya buat keluar magic pen saya ni. Okay, latitude, kamu nampak tak saya tengah menulis ni?
Nampak, madam.
Okay, latitude,
Baik.
what you need to remember is come from the word flat. Flat. Okay. Kalau rumah flat tu macam mana? Okay. The building the flat you have a multiple level kan?
Tinggi.
Dia tinggi kan? Macam bertingkat-tingkat kan? So this is your latitude. Nampak miss pula dot tu. Okay. Maksudnya dia bertingkat-tingkat. Okay. So this is your latitude. Okay. Remember the word flat So what is the reference for this latitude? Reference dia apa? From 0 to 90 degree on the north and 0 to
90
90 degree to
south.
the south. So reference dia apa? Equator. Okay, the reference is equator 0 degree. Okay, kalau to the north, dia dah 90 degree. To the south also 90 degree. Okay. So please remember this is for latitude. Okay, what about longitude? Okay, longitude. The reference is reference dia apa tadi?
Long.
Yes, the reference is Greenwich Meridian somewhere in UK contohnya saya lukis kat sini Alamak tak berjalan. Alamak tak cantik dah pula. So let's say Allah. Tak boleh lah. Dia sensitif sikit. Tak apalah saya ambil line yang ni Katakan greenish kenapa dia tak nak lukis ni? Oh, dia tak boleh atas ni. Okay, contohnya saya letak sini dekat saya lupa nak tukar eraser tadi. Taklah tak boleh lukis. Okay, let's say this is greenish greenish in UK. Okay, so start from here is a 0 degree dia punya line tu 0 degree. Okay, so the reference is Greenwich Meridian. Okay, how to remember this? You just remember the word long So, kita ingat, remember long hair. Kalau rambut panjang, mesti daripada from the top to down Okay, daripada atas ke bawah. So, rambut ni memang ada banyak-banyak lah kan? Daripada atas bawah kan. Saya lukis tak cantik. Okay, ignore je. Okay, atas bawah. Okay, so this one represent by the long hair. Remember the commercial, the shampoo commercial for the long hair. So the model will flip the hair to the left and to the right. Maksudnya kalau left and right tu maksudnya represent west and east. Boleh ingat dia macam tu okay. Urutnya saya punya lukisan ni ignore je lah Okay. Oh, dia dah ke lari. Okay, that one is latitude and longitude. Latitude reference is the equator. Longitude, the reference is Greenwich Meridian. So this is how they looks like longitude and latitude. Yang ni lah. Equator naik ke atas until 90 degree. So we already reach Arctic Another one from 0 to 90 degree. Ialah Antarctic And then this is the greenish meridian tadi dekat sini. Okay, from this is east, this is west. So the difference is 80 degree here and 80 degree here. So total up for one circle for longitude is 360 degree. Any question so far? Ada soalan tak?
So far so good, madam.
Okay. For clear view, boleh buka, you can open my another file. Sekejap Saya ada letak sub chapter for chapter number 2. Okay, for clear view, you can refer to this one. Okay, this one is longitude. Okay, so the total is 360 degree from Greenwich Meridian. This one for Equator 290 degree ni nampak sikit. Okay, so this is longitude, and here in this direction and below is a latitude. Okay, saya buka balik tadi, open back my file tadi. Okay, let's see the altitude the names of the latitude So you need to remember 3 important latitude, which is equator 0 degree. Another one is Tropic of Cancer, which is 23.45 degree north. Okay, you need to remember this location the degree 23.45 degree north for Tropic of Cancer. And another one is on the south part is Tropic of Capricorn, which is 23.45 degree south. Okay, and then we have Arctic Circle 66.55 degree north, and Antarctic Circle, this part 66.55 degree south. Okay, this one easy to remember. But please don't confuse between these two Tropic of Cancer and Tropic of Capricorn. Okay, sekejap saya lukis. Okay, for Tropic of Cancer, what you need to remember is Cancer. Cancer represent, sebenarnya Cancer ni is the name of the constellation the star. Tapi saya nak bagi kamu ingat, to make sure you remember, you just represent Cancer is a top disease, right? The top disease, penyakit yang paling top sekali is the Cancer. Okay, so you remember kalau top is on the north. Okay. Okay, another one is Tropic of Capricorn, sebab Cancer ni dia dah top, dia mesti duduk dekat north So Capricorn is opposite lah, on the south. Okay. So declination angle, of course similar to this one. Ni matematik ke ni? Okay. Sebab yang ni dah 23.45 degree north. Of course the declination angle pun sama about 23.45 degree. Okay. Any questions so far? So again this is the longitude. Okay, very good. Okay, the earth rotate decline maksudnya the earth rotate a little bit decline, dia bukan rotate macam bola dia a little bit decline. This is how the earth rotate. From this declination you will get this 4 season lah. Okay. Okay, I will proceed to the next page. Okay, tadi saya dah tunjuk declination of the earth. And then you have Tropic of Cancer, Equator and Tropic of Capricorn Okay, what about this axis of magnetic poles? Okay, your compass will follow which one? Axis of rotation or axis of magnetic poles?
Axis of magnetic pole.
Okay. So compass will follow this one, axis of magnetic pole, which is 10 degree from this declination angle. Okay. So this is the important latitude that you need to remember: Tropic of Capricorn, Tropic of Cancer, and Equator. Okay, siapa tu yang duduk tepi pantai tu berangin-angin tu? Boleh tolong mute ya. Okay, sun position. Okay, this is example. Here is the collector. Collector ni for example your PV module. So this is the altitude angle. Okay, you need to imagine this one in 3D. Kena imagine 3D. Jangan imagine 2D. Kalau you imagine 2D, tak nampak. Okay, you must imagine this one in 3D. So this is north, this is south, west and east. So this is your earth surface, horizontal plane. So this is your PV module. So the sun will rise here. Okay. So this angle we call altitude angle. Okay. Ataupun when you in the flight, so the pilot will announce, okay, now we are at the altitude 30,000 feet from the ground. Yang tu maksudnya ketinggian, the altitude. Okay, so this is the altitude angle of the sun. So this red line represent the sun ray lah, the beam radiation. And this is azimuth angle. So what is azimuth angle? So azimuth angle defined as the angle between the projection of the sun ray on a horizontal plane and the south direction. So your south direction is your reference. Lepas tu dia ada daripada south. This is your reference. The angle to the east are negative, while to the west are positive. This is used for solar energy engineering in the northern hemisphere. So this one, for example here, let's say saya letak yang ni 90 degree lah. Okay. Okay. Katakan dia punya sun tu jatuh dekat sini. Dia punya altitude ketinggian tu. So this is 90 degree. So the azimuth angle is positive or negative? Kalau ke sini?
Negative.
So negative 90 degree the azimuth angle. Katakanlah matahari dekat sini pula. Okay, satu kan saya lukis dia jatuh kat sini, ketinggian dia. You need to imagine in 3D matahari kat lemak. Tak cantik lah lukis. Okay, ni cahaya matahari okay. Katakan yang ni 100 degree. Berapa azimuth angle?
Positive 90.
Positive 90 or positive 100?
Positive 100.
So your azimuth angle will be positive from the south. From the south as a reference, so your azimuth angle will be positive 100 degree. Faham ya?
Faham.
So altitude angle defined as the angle between the sun ray and the horizontal plane. Okay, tadi dekat sini. So this is the altitude angle. Sometimes they call alpha. Benda yang sama. Yang ni pula dekat sini lah tadi. Altitude angle dia. Alpha. Okay. Okay, how to calculate this solar altitude angle? There are two cases. Okay, case number 1. Your position and the sun are both at the same hemisphere. So how they divide this hemisphere? Tengok balik yang ni. Okay, from equator. For equator tadi 0 degree ke atas So this is north hemisphere. Yang 0 degree to the south. Belah sini pula. This is the south hemisphere. Okay. Okay, case number 1, your position and the sun are both at the same hemisphere. Maksudnya apa? Example here, you are on the north, okay, and the sun also on the north. This one they draw in 2D Okay, now the sun is near to the south but it's on the north hemisphere, right? Okay, contohnya kita ambil matahari dekat sini. Okay, kita lukis matahari dekat sini. Saya ambil pemadam pula. Okay. Matahari dekat sini. Okay, let's say matahari dekat 5 degree north Ini sangat ni matahari ni. Okay. Let's say sun is here. Okay, dia dekat sini kan dia punya cahaya dia. Let's say sun at the 5 degree north and you are here at Tropic of Cancer. Kamu dekat sini. Okay. So you need to find the altitude angle of the sun. Kat sinilah altitude angle Okay, so this 3D represent in 2D using this figure. Okay, berapa tadi sun? 5 degree north and you are at the 23.45 degree north dekat Tropic of Cancer. Okay, setakat tu faham tak? Hello?
Faham.
Faham
Faham.
Semua senyap. Tadi saya
Takutnya
cakap seorang
video
tak? Okay. Macam ni boleh nampak kan? Okay, sun at the 5 degree north, you are at the Tropic of Cancer, 23.45 degree north. Okay, now you need to find the altitude angle. Dekat sini. Altitude angle here. So, first you need to find this angle. Okay, so angle X minus Y. So, X minus Y tadi 23.45 minus 5. Okay, dapat berapa tadi? 18.5
45.
degree Okay, 80.45. So yang ni matematik saja. So this angle equal to this angle, but this is 90 degree. Okay, sini 90 degree. So 90 degree minus to find altitude, 90 degree minus 18.45 degree. Dapat berapa tadi? 71.55 degree. So the orientation is facing. Kamu nak tengok matahari ni kan? Kalau ada PV module, kamu kena facing mana ni? Facing south. Okay. Maksudnya kamu dekat atas north tapi ke matahari dekat bawah. So kamu menghadap south. Okay. Kalau 3D macam ni lah. Okay. Kamu dekat sini, matahari dekat sini. Jadi kamu memandang ke, you are facing south direction. Faham
Faham.
Okay, let me add your PV module. Saya tak nak guna orang dah. Saya nak ganti PV module kat sini. So PV module on fixed structure, it should be perpendicular with the sun ray. Okay. Ni saya gantikan dengan PV module kat sini. Ini side view Faham tak side view? Maksudnya PV module kamu tu macam ni ya. Side view. So your PV module should be 90 degree perpendicular, maksudnya dia 90 degree facing the sun ray. Ni 90 degree kat sini. So what is your tilt angle kat sini? Tilt angle. Sudut ke tilt tu apa? Kecondongan. Okey? Berapa tu? Beta. Satu nombor satu. Berapa tu? Tilt angle? Yang ni dah 90 degree. Kan? Angle ni pun dah tahu dah.
18.45.
18.45 degree.
Yes, madam.
Okay, how you get that angle? Macam mana tu dapat tu?
180 minus 90 minus 71.
Okay. Kan boleh buat kira jalan jauh kan? Macam ni. This is 180 degree. Kan? 180 degree minus 90. Kan sini kan ada 90. And then minus your altitude angle tadi. And then you get this angle, right? So this angle equals to this angle. Okay. This angle equal to this angle or not? Sama tak? Ini sama tak lah angle ni? Sama kan ukur segitiga? So this angle equal to this angle. So actually when you find this angle, you already find your beta. Terus ambil yang ni. Okay, this is your the angle or beta. Okay. Okay, let's try another one. Also same hemisphere, but it's on the south. So you are on the south, the sun also on the south. Kita ambil contoh ni. Okay, first again, you draw this straight line. Make sure your the south is on the right, the north on the left hand. Okay. So this is you here, this is the sun. Okay, saya ambil satu contoh. Saya buat tadilah. Okay. You are at 5 degree south. Sekejap. Saya ambil 5 degree. Tapi yang ni ke north Maksudnya yang ni yang kena 5. Lepas saya ambil. So you are at 5 degree south. Yang ni kita ambil tropic of, we take tropic of Capricorn Capricorn, which is 23.45 degree south. Okay. Kenapa yang ni 5 degree south? Because this is already near to the north, right? Faham ke tak faham? Saya bagi contoh kat sini. Because this is south, which is in the south direction, right? Okay, maksudnya matahari tu dekat sini. Okay, dekat Tropic of Capricorn. This is south, And then you are here at 5 degree, 5 degree south. Okay. So from here, you find the altitude angle here. Okay. Cuba kira. Dapat sama tak tadi? So what is the angle? Hello? Putus ke?
Tak medium, tak.
Okay.
Medium maksudnya kan. Dua-dua ni kat south lah maksudnya.
Dekat South Hemisphere. Sebab konsep dia, your position and the sun are both at the same hemisphere. Same hemisphere tu maksudnya PV module dekat north, matahari dekat north. Kalau PV module dekat south, matahari pun dekat south. Same hemisphere. Berapa angle ni? Saya repeat benda yang sama kan?
Medium. Okay. Faham.
Minus 5. Dapat berapa tadi?
18.45.
19.45.
Okay. So ni buat 90 degree. Maksud saya ingat lah lukis ni. Ni 90 degree. So this angle equal to this angle. That's why you get 90 minus x minus y tadi kan. This is your x minus y. So 90 minus 18.45 degree. Dapatlah tadi 71.55 degree. Okay. So that one is your altitude angle alpha. Okay. So this one facing south or facing north?
No. Facing north.
Facing down.
Enough.
You are facing
No.
north saya salah lukis lah tadi. Saya dekat 23.45. Okey, yang atas ni salah tadi. Maksudnya matahari dekat sini 5 degree. Kamu kat sini kan? You are here. So actually the altitude angle is here. Salah tadi. Okay, okay. Okay, you are here. This is altitude angle of the sun tadi dekat sini. Okay, now the orientation is facing north because the sun is on the north 5 degrees, even though it's on the 5 degrees south, but the facing the direction is on the north. Okay, so it's facing sekejap facing north. Okay, so T angle sama macam tadi so the T angle, this is beta. T angle, you can take this one which is 18.45 degree facing north. Okay. That one with the same hemisphere. Okay. Case number 2 is your position and the sun are at the opposite hemisphere. Okay. Your position and the sun at the opposite hemisphere. Example here, you are on the north, but the sun is on the south. Okay, maksudnya solar module tu ataupun solar farm tu on the north hemisphere, but the sun during that month, the sun is on the south hemisphere. So saya ambil contoh sini. Saya ambil 5 degree north You are on the 5 degree north, but the sun is at the Tropic of Capricorn 23.45 degree south. Cuba kira. What is the altitude angle? Ni tambah ke tolak? You add or you minus?
Add.
Okay. Please remember you have equator here. Equator dekat sini. Here is your equator. Equator 0 degree. Okay, you must draw logically because this is 5 degree north. Equator mesti dekat near to 5 degree north. So this is equator to Tropic of Capricorn which is far away from this one. So this is 23.45 degree. You need to add here plus this one plus this one. Okay. 23.45 plus 5 degree. So you get 28.45 degree. Okay. So this is 90 degree. Okay, now you find your alpha. So 90 minus 28.45 degree dapat berapa?
61.55.
61 0.55 degree facing
South.
facing south because the sun is on the tropic of Capricorn. So T angle T angle pun benda yang sama. You can calculate 180 minus 90 minus your altitude angle, or you just take this angle which is 28.45 degree the T angle. Okay. Continue with another one. Opposite hemisphere, which is you are on the south and the sun is on the north. Example here, 23.45 degree north, which is Cancer, Tropic of Cancer. You are at the 5 degree south. So here is your equator, 0 degree. So this is south, this is north. Again, you calculate this angle, and then from this angle, 90 minus this angle, you get the altitude angle. Easy, right? Senang je ni.
EF.
Easy, madam.
Alright. So actually this is the easiest calculation part for this subject Example 1 lepas ni boleh congak-congak je Example 1 I already show you the altitude of the sun when the sun is solar noon. At solar noon means solar noon ni maksudnya apa? When the sun is at solar noon and above the solstice of Capricorn.
90.
Solar noon means the sun is exactly on the top of the solstice of Capricorn ataupun tadi apa? Tropic of Capricorn. Okay. So the sun is above the Tropic of Capricorn. Okay. Betul-betul atas kepala Maksudnya betul-betul on the top of Tropic of Capricorn. But you are on the 5 degree north. So which case? Case 1 or case 2?
Case 1.
Case 1.
Case 2.
Case number 2, which is opposite hemisphere.
Hemisphere.
Okay. You are the altitude of the sun. The sun is on the south, but you are on the PV side is on the north. Ini case number 2 case number 2 ingat balik. Kami imagine balik tadi yang kamu lukis tu. Jadi 5 plus 23.45 because opposite hemisphere. So tak payah lukis balik lah ya. You just imagine how we get this. And then 90 minus 5 plus 24.5. So 61.55 facing south. Because the sun is on the south Capricorn. Next one, the altitude of the sun when the sun is at solar noon and above the equator. Now the sun is above the equator, 0 degree. But your side is on the north kan, 5 degree north. Okay, balik tadi. Yang ni south. Yang ni north. Matahari dekat equator. Ni equator 0 degree. Berapa altitude angle? Yang ni paling senang sekali. 5 plus 0 lah kan. Ni 0 degree. So 90 minus 5 plus 0 tadi kan. Dekat sini. Okay, you get 85 degree. Tertinggal. Unit semua tertinggal kat sini. 85 degree facing south Another one is altitude the altitude of the sun when the sun in at the solar node and above the solstice of Cancer. So this one case number 1, which is the
One.
atmosphere. Okay. So dapatlah yang tadi kita ada kira 71.55 facing north because the sun is on the north. Facing north Okay. Okay ke tak okay? Setakat ni. So
Okay,
far?
okay.
So far so good.
Okay, so far so
Madam,
good Ya.
saya ada soalan untuk yang kedua tu. Kan dia berdiri dekat above equator. Kenapa dia masih facing south?
Okay, now the sun is on the top of the equator, right? The sun dekat sini, but your PV side is at the latitude of 5 degree north. Okay, you are here. Okay, so this is south direction, this is north direction. This is direction and it doesn't mean it's on the south, the direction. Okay, when the PV module is here, saya lukis PV module kat sini. The side view ada mesti 90 degree. Okay, now the PV module must facing the sun, right? So which direction? Dia facing on the north direction or south direction? The north direction or the south direction?
Okay, faham. South.
The PV module must facing the sun on the south direction. Faham
Okay,
Tadi
faham.
dia punya
Thank you.
direction ni.
Faham
Dia
madam?
direction.
Number 3, madam.
Number 3, okay, altitude. Okay, your PV side on the 5 degree north, but your the sun is at the solar node and above the solstice of Cancer. Tak apa, kamu lukis dulu. Just draw this arrow. This is south. This is north. Now your latitude, the PV side is latitude 5 degree north. Lukis dulu equator kat sini. Kalau tak nak confuse, just draw the equator first. 0 degree, right? 0 degree. And then you are here, 5 degree north. Okay, this is 5 degree north. Where is the sun? The sun is at the solar node and above solstice of Cancer. Solstice of Cancer is more than 5 degree, right? Maksudnya dia kat belah sini. 23.45 degree north. So the sun is here.
Oh, solstice of Cancer tu dekat north, madam.
Solstice of Cancer ni, your Cancer ni on the top. Maksudnya dia north. North Kalau yang Capricorn tadi on the south.
So,
Okay. So yang penting you draw this one first. The arrow, this is south direction, this is north direction. You mark first your equator dulu. Okay, so this is 5 degree. And then the sun is at Tropic of Cancer, right? So it will go further to the north side. So here is the sun on the 23.45 degree north. And then you calculate the altitude angle. Okay, so first you need to get this one first. So to get this one, 23.45 minus 5. Dapat yang ni And then this is 90 degree. Ini 90 degree. So this angle equal to this angle. That's why 90 degree minus this angle. You get 71.55 degree facing north. Okay. Because the sun is on the north side. So this is your PV module. PV module ni must facing the sun lah. Okay. That's why you facing north. Okay. Faham setakat tu?
Faham.
Okay.
faham madam?
Okay. I will proceed to the next one. MS. MS is a relative measure of the optical length of the atmosphere at sea level when the sun is directly overhead. Zenith angle equals to 0 degree. The sun is here, so no theta lah. Okay, 0 degree. The MS is equal to 1. Okay, because 1 divide with cos 0, we will get 1. As the zenith angle become larger, the path of the direct sunlight through the atmosphere grow longer and air mass increase. So the green color is your hemisphere. So when the sun goes here, so the path will become longer, right? Okay. So when the path become longer, what happened to air mass? The air mass will increase. Okay. In contrast, as land elevation increases, the thickness of the atmosphere lessens and the air mass is reduced. Okay. Contohnya, katakan kamu, alamak, terconteng pula. Sekejap katakanlah kamu dekat atas bukit saya lukis bukit kat sini. Katakan kamu dekat sini atas bukit. So the elevation angle ni dekat sini lah kan. Salah. Sekejap dekat sini lah kan. Alamak, macam tu. Okay. So pendek je kan. Here So this one represent this one. As land elevation increase, the thickness of the atmosphere lessen, the air mass is reduced. Dekat sini saja So the air mass will reduce. The relative air mass, AM, is simply a trigonometry function of the zenith angle. So air mass ikut trigonometry function kan, segitiga ni kan. Okay, so air mass equals to 1 over cos theta. Okay, so you will get the air mass. So where theta is the angle from the vertical zenith angle, when the sun is directly overhead, the air mass equals to 1. Okay, kalau theta equals to 0, maksudnya the sun is here. So 1 over cos 0 will become 1. 1 over 1. So become 1. Ini matematik saja. Faham ke tak faham? Okay
Okay, madam.
InsyaAllah. Okay, madam.
Okay, madam.
Okay, what is MS? Dalam nota ni tak ada. What is MS? MS apa tu?
Length of hypotenuse divided by the object height and from Pythagoras theorem.
Okay. The definition of MS. Is it related to the temperature, the moisture of the air? Apa tu MS?
Shadow.
Google. Apa? Definition of MS. MS tu apa? This is how you find the MS. But what is MS? MS tu apa?
Dekat atmosphere.
MS is the volume of
Air.
the volume of air. Okay. So the volume of air which is defined in terms of temperature and the moisture. Moisture of the air. This one I just explain how to calculate the air mass. Okay. Another method is by using the shadow. An easy method to determine the air mass is from the shadow of a vertical pole. So this is your vertical pole and this is the shadow of the vertical pole. So air mass is the length of the hypotenuse divided by the object height, and from the Pythagoras theorem, so air mass is 1 plus s over h square and square root. Okay. This is theorem Pythagoras. So you will get the air mass here. Daripada sini This simply approximation is quite accurate for zenith angle less than 80 degree. When the sun is near the horizon, more complex and accurate model are necessary. Okay, yang ni untuk zenith angle which is less than 80 degree only. Okay, it's more than this, you cannot use the concept of vertical poles ni. Okay, next one, irradiance, irradiation and peak sun hour, PSH. solar irradiance. Okay, this is the symbol. G is defined as the intensity of solar power at a point of observation. So the unit is watt per square meter. So this is power. Power we use watt, which respect to the area of the point of observation, which is square meter. But solar irradiation, so this one, the symbol is H, is defined as the intensity of solar energy. So this is energy at the point of observation. So energy, the unit is watt hour per square meter. Okay, please remember and don't confuse between power and energy, because energy we have this rate, the unit in hour. Okay, in terms of irradiance, solar irradiation reaching Earth's surface can be divided into the following component. So G global, so G is your solar irradiance, equals to G direct plus G diffuse. Okay, what is G global? G global is the sum of all the component of solar radiation or solar irradiance that arrive as a point of observation. So this is the unit. Remember, this is power. G direct is the component of solar radiation or solar irradiance that has traveled in a straight path from the sun to the point of observation. An object in the path of direct radiation will cast a shadow. So again, same unit, power. G diffuse is the component of solar radiation which arrive at the point of observation after scattering due to clouds, fog, haze, dust or other particles in the atmosphere. It is more or less uniform from all directions. Also same unit because this is solar irradiance. So all these statement represent by this figure. Kalau straight sampai ke bawah ni, what we call this one? G apa?
Global.
G global dah tambah dah. Ni dia direct
Diffuse.
from the sun terus sampai to the
G direct.
collector.
Direct.
So this
Direct.
is G direct. Okay, what about this one?
Diffuse.
G
Diffuse.
So this is G diffuse. This is cloud Cloud ni
Yes.
dah tertinggal dia punya UD. CLOUD actually this one. So from the top of the hemisphere, so this is the value of solar irradiance or solar radiation, which is 1367 watt per square meter. So this is the diffuse, okay, and this is the global solar radiation at sea level, which is G naught for at the sea level, which is 1000 watt per square meter. Okay. So solar irradiance that reach to the top of the Earth atmosphere is 1367 watt per square meter, or yang ni dia convert to kilo So for kilo is apa yang salah ni?
Titik tak ada.
Tak ada titik. This is 1.367 kilowatt per square meter. Nanti saya buat pembetulan tinggal titik. So this value is called solar constant and usually symbolized as GSC. So this concept can visualize and show in the following figure. Okay, can you guess when the sun reach to the Earth's surface, agak-agaknya berapa? What is the value of the solar irradiance when it reach here? Okay, from the top is 1367. After it reach the Earth's surface, how much the value? Can you guess?
100.
Berapa? Tak dengar sangat. Berapa?
1000.
1000.
500.
100? Sikit sangat tu 100. Itu semua.
5.
Okay, 1000 at the sea level. Example in GARC, Green Energy Research Center at Kolej Teratai, UiTM. We have record about during March, March and September. So the solar irradiance can reach up to 1300 watt per square meter. Tinggi boleh sampai 1300 watt per square meter. Sikit je reduce from the outer hemisphere to the surface of the earth. Especially for the location that near to equator. We are near to equator. Okay. Solar irradiance reaching Earth's surface. So this is the unit, the symbol, and this is the unit. Okay, you must remember all these 4 points. It is quite common solar irradiation data recorded by meteorological department are in the unit of megajoule. So the conversion factor from megajoule to kilowatt hour is as follows. So 1 kilowatt hour equals to 3.6 megajoule. Often in PV system design and sizing, a more practical approach is by the use of a concept called peak sun hour, PSH. Okay, you need to remember this definition of peak sun hour. Peak sun hour can be defined as the equivalent number of hours in a day when the solar power intensity is 1000 watt per square meter. Okay, that's mean how many hours in one day that the solar power or solar irradiation is exactly at 1000 watt per square meter. Okay, what about Malaysia? What do you think the number of peak sun hour? Berapa Malaysia? Can you guess? The peak sun hour? 2 hours? Lagi?
4 hours.
4 hours.
4 hours.
Okay, about 4 to 5 hours. But in Kedah, Perlis, it can go more than 5 hours. Depends on the month. Musim panas ke musim hujan. Kalau musim panas, it can go more than 5 hours per day for Kedah, Perlis, Pulau Pinang. Okay. So to convert megajoule per square meter to peak sun hour, divide the number of megajoule per square meter by 3.6. Therefore, to produce 6.94 kilowatt hour of energy per square meter, the radiation will have to continue at the rate of 1000 watt per square meter for 6.94 hours. Thus, the number of peak sun hour is 6.94. So how to convert this one? Now you have the energy is 6.94 kilowatt per square meter. So 6.94 kilowatt per square meter. Remember back the peak sun hour definition, equivalent to number of hour in a day when the solar power intensity is 1000 watt per square meter. So peak sun hour equals to 6.94 kilowatt per square meter divide with 1000 watt per square meter. So you cancel this one. You cancel this one. Kilo, you cancel this one. So you get 6.94 hour. So this is your peak sun hour. Okay, kat mana tu? Which country that have this peak sun hour 6.9 hours ni?
Kedah.
Kedah. Habislah orang Kedah ni. Kat mana tu? You can refer to this map. Kat Kedah ada gurun je kan? But it's not like a desert, right? Nama je gurun kan? Tapi bukan gurun.
Mesir.
Dekat mana tu? A part of Saudi Arabia here. Dekat sini ada Egypt, right? Egypt. This is a part of Sahara Desert. This one can reach up to 6.9 hours per day, the pisan hour. Australia pun ada. The desert in Australia. Yang ni Botswana kot, saya tak ingat. Ni Afrika. Ni dekat sini.
Madagascar.
So this one Madagascar dekat sini. Betul ke Madagascar kat sini?
Tak mesti
Saya tak
lah.
ingat. Madagascar dekat area sini ke? Nanti kamu check Okay. So all this part they have peak sun hour which is 6 to 6.9 hour per day. Okay. This is Malaysia. Okay, Malaysia which is between berapa tu? 4 to 4.9 4 to 4.9 hours, but we have record the data for Kedah and Perlis which is actually more than 4.9 hours per day. Okay, that one for the world map. Okay, for Malaysia. Okay, the hottest place is
Kota
Penang,
Kinabalu.
Penang, Kota Kinabalu, Seberang Perai, also Kedah and Perlis also Kedah and Perlis, and also Kota Baru.
Alam.
Okay, on the south part, okay, macam Johor,
Kuantan.
Seremban, Kuantan, on the border So they have less solar irradiation maksudnya dia kurang lagi. Kuching and then sini apa? Sibu dengan Mukah, tak salah saya, okay. They have less solar irradiation compared to the north part Can you see the pattern? On the north part is much hotter than the south part. Okay. That's why our solar farm focus more on the south punya part the south of Malaysia. Banyak area Kedah, Penang semua tu Okay, any question? Pukul berapa dah?
No, madam.
Aduh, lagi 30 minit. Measurement of solar irradiance. So measurement of solar irradiance is very important in designing and monitoring the system related to solar. Equipment to measure solar irradiance. So this is the equipment Amplipyranometer. So in GARC, when you do your PV lab you did your PV lab and then you use this one, right? Licosolarimeter. Is it correct?
Yes.
This one, right? This is the dome type. This one is a licosolarimeter. Another one is by using the reference cells. Okay, reference cells and then attached to the meter. Okay, so this is the three type of equipment to measure the solar irradiance. And this is the equipment to measure the shading profile of the location. This is called solar path chart. This is also you have done in your lab section. So this tool is used for shading analysis. It is very useful for solar PV system design. The brand is Solar Pathfinder. So in this Solar Pathfinder, you will plot the shading. The shading. But before that, you must make sure that you use the correct Solar Pathfinder. For example here in Shah Alam, we use 0 to 4 degree north latitude. Okay, inshallah we can use this solar chart. But if you are at Kedah and Perlis, you cannot use this one. Kedah, Perlis, Penang, the latitude is more than 4 degree. You should use for 4 to 12 degree north latitude. Okay, you must check this first. Okay, this is how it looks like. And this is the plot for the month, June, July, May, August, April, September, March until December. Okay. So this one you use for your lab section. Betul ke tak betul? Is it correct?
Yes.
Yes, madam.
Okay.
Yes, madam.
Yes.
Okay, what is the magnetic declination angle for Malaysia? Berapa kamu set during your lab? How much? What is the value for magnetic declination? Yang ni. For Malaysia?
Tak ingat dah, madam.
Tak ingat dah.
Tak ada set pula, madam, sebab
Tak ada
dia,
set.
Kita orang
Rasanya Mai Sarah ingat, madam.
Pas kat Maisarah pula.
online.
Kita orang virtual, madam.
Kita orang online lab.
Mai Sarah sempat buat.
Online?
Mai Sarah sempat buat lab
online.
Okay, now I remember you did your virtual lab, right?
Yes, madam.
Masalah tak tahu.
Yes.
So, if you have the solar pathfinder, okay, please search in YouTube. In YouTube, how to set up this solar pathfinder. Saya ada link ke kat sini? Oh, saya tak ada letak link lah. Okay, please search in YouTube how to set up the solar pathfinder. So the channel's name is also solar pathfinder dalam YouTube tu. Okay, to set up this one, you have this white dot here dekat sini before you put the dome. This is the dome You want to watch the video now or later? Nak saya buka sekarang ke?
later, madam.
Later, madam.
Later
Later, madam.
So that white dot should the white dot should be on 0 degree, which is for Malaysia magnetic declination, which is 0 degree. So white dot will be here, and then you put the dome, the black color with the yellow ring here. You put the dome, and then you trace the shadow. You trace the shadow here using special marker, or you just snap using your handphone. Okay, these people snap we're using the handphone. Okay, from that one you can know the shading profile for that place. Okay, let's see the example. The unshaded solar irradiation data at Kampung Baru is given in table A, and the shading profile at the site is shown in figure A. So this table A is the value of solar irradiance unshaded, maksudnya tak ada shaded. So this data actually you can get from the meteorological department, but you need to buy the data. You cannot get it free. You need to buy the data. So this is example per month, from January to December, and this is the total number of solar irradiation for 1 year. And then this is the shading of that place. For example here, the shadow is here. It will cover all this place. Sini it will cover all this graph here. So how to calculate this one? We start with January. Sekejap saya zoom sikit. January. Okay, mana January? Okay, January. So on January, this line, there is no shadow. Okay, so January is equal to unshaded solar irradiation, same. Okay, so percentage of shading are 0 degree. So available solar irradiance is 125. Okay, so the value you just take from the unshaded solar irradiation. Okay, so February also no shadow. Okay, let's see for March. March. Tengok March. Okay, March is here. So this is 1 plus 1 plus 2 plus 3. So total is 7
7.
Okay, that's why your shading percentage is 7. 7 here. So 7 from March is 140.9, the unshaded. You multiply with 0.93. Okay, because 7% shading, so the left one is 0.93. And then you will get 131.037. Understand? Boleh Then you calculate.
Boleh madam.
Okay, then you calculate from January until December. But please be careful. For example, okay, for October. October, how much the shading? The percentage of shading? Please be careful because this is the border between one here and one here. So this is only 1%.
1%.
Okay, what about May? Masuk ke tak masuk ni?
Masuk sikit.
Masuk
Masuk
sikit.
sikit kan?
Ha.
So it's already enter this area. So you need to
Yes.
count this one. So May is 1%.
Percent.
Okay. So you total up all. Okay. You minus the shading. You total up all. And then you get 1522.373. Okay. What is the question? Dia tanya. Sekejap. Okay. Number 1 is describe solar irradiance and solar irradiation. Okay, you need to define what solar irradiance, which is power, and solar irradiation is the solar energy. Okay, number 2, which month has the highest solar irradiation? What is the value? Okay, the highest solar irradiation is, this is without the shading. The highest one is 140.9, which is on March. Yang lain semua rendah. Okay, but when the question said the highest solar irradiation on that location after the shading profile, lepas dah buat shading profile, which month is the highest? Mana?
February.
February, the highest one. Okay, after you did your shading profile, the highest solar irradiation is February. Okay, next question. Determine the actual peak sun hour per annum received at the site. Okay, so you need to calculate peak sun hour. Please remember this is per annum. And the last question is also peak sun hour, but this one is daily. Okay, so number 3 is peak sun hour per annum. Number 4 is peak sun hour daily. So how to calculate peak sun hour per annum? So again, you convert the unit, the solar irradiation into the peak sun hour, which is you divide with 1000 watt per square meter. Okay, I already show you before this. So you divide with 1522.373 divide with 1000. Okay, kamu divide. So you cancel this one with this one. This one with this one. This one with this one. So you get 1522.373 hours. Okay, this is annually, annual peak sun hour. Okay, to get the average daily peak sun hour. Nak buat macam mana? So 1522, this one is annually, right? Okay, to convert to daily, you need to divide with
Annual divide by 12 and divide by
365.
how many days per annum? Per annum, how
365.
many days?
365 madam.
5 days, right? Okay. So you divide this number with 365 days. So you get 4.17 hours. Okay. Ada soalan tak setakat tu?
Tak ada madam.
Senang je kan?
Tak ada doktor.
Senang.
Okay. We already finish Okay. Let's do one exercise. Okay. Let's go to Gaisma here So Gaisma is actually a website that monitor the real time the real time of the sun path for the whole world. If you go to Gaisma, you can find Shah Alam. You can see the sun path during for today. Okay. Let me show you one example here for this question. Question number 5. The solar path diagram of Shah Alam on 1st September 2015 is shown in figure question 5. Determine the sun altitude and azimuth angle at 10 AM civil time. 10 AM civil time means the time of your clock. Okay, maksudnya jam tangan kamu tu, we call is a civil time. Okay, but in your solar pathfinder, kita tengok balik, this is not civil time This is solar time. Okay, what is the difference between civil time and solar time? Apa beza dia? Ada siapa
solar.
tahu?
Solar ikut matahari.
Okay, the solar will follow the
Sun.
the path of the sun For example here, solar noon. Solar noon is when the sun is exactly on the top of your head. Okay. So agak-agaknya pukul berapa solar time? For your civil time?
12.
Kamu solat Zuhur pukul berapa?
Masuk solat Zuhur madam.
Solat Zuhur pukul berapa tadi?
Dah
Satu.
masuk asar dah.
Satu.
Solat dah madam.
Kan?
Berjemaah.
Satu.
Okay. Pukul 1. Okay. Apa jadi matahari during solat Zuhur? What happened to the sun during that time?
Tegak.
Dia tegak ke dia tergelincir daripada tegak?
Tegak.
Tegak.
Tergelincir sikit.
Gelincir.
Waktu Zuhur is when the sun is dia start to tergelincir. What in English tergelincir? It's already past the solar noon maksudnya dia baru tergelincir daripada tegaknya matahari kat kepala tadi. Baru masuk waktu Zuhur Okay. So actually 1 o'clock today. So your solar noon for today is about 12 o'clock. Okay. About 12 o'clock solar time, which is about 11:59 PM today. Maksudnya dia tak tergelincir lagi. Dia tergelincir pukul 1 kan? Civil time, right?
Yes.
Okay. So sebelum dia tergelincir is 11:59 PM civil time. Okay, during that time, that is your solar time So solar time for today Okay, you said 1 o'clock tadi. Zuhur time kan? Which is tergelincirnya matahari kan? So before 1 o'clock is 12:59 PM. So this is your civil time. Which is equal 12 pula. 11 lah. Betul lah. Betul lah. Sekejap Equals to 12 solar time. Which is the sun is exactly on the top of your head lah. Itu atas kepala. Okay. Do you understand? Faham ke tak faham? Okay, silver time is your watch time and this is the solar time, which is the time of the path of the sun. So in this question, the sun altitude and azimuth angle at 10 a.m. civil time on the 1st September 2015. So this is the 1st September 2016 today in this example. So all this dot is your civil time. Okay, semua ni civil time So the question said the sun altitude and azimuth angle at 10 a.m. civil time on the 1st September. Okay, where is your 10 a.m.? So this is 7, this is 8, this is 9, this is 10. So here is your 10 a.m. Kat sini 10 a.m. civil time. So the question said find the altitude and the sun altitude and the azimuth angle. Okay, how to find this altitude angle? Macam mana nak cari? So this one, this all the circle So this is 0 degree, 10, 20 until 90 degree here. All this circle represent the altitude angle. So berapa altitude angle ni? Kamu tarik. So what is the altitude angle here?
50 ke?
50? About 40 berapa ni? This is 50. About 43 degree, right? Okay, about 43 degree. So at 10 a.m. the altitude angle. So at 10 a.m. the altitude angle is 40 degree. Okay, this is the altitude angle. Okay, next question. Find the azimuth angle. Okay, for azimuth angle, you take a ruler and you make a straight line from this zenith angle tadi betul kat atas tadi and cross the point here 10 a.m. Mak saya buat tak cantik lah. Okay, from here you cross the 10 a.m. and this is your azimuth. Berapa azimuth angle? Remember back definition of the azimuth angle? Which is the reference is from the south, right? Berapa tu? Kira. From the south to this point. How much? Azimuth angle? Okay, from here to here, how many degree?
90.
30.
90.
30. This is 30.
30.
Okay. And then here is another 30 degree. Agak-agak sampai sini berapa? 10.
100.
Dalam 9.
100.
Another 10 degree right here.
Lebih kurang.
30 plus 30 plus 30 plus 10. So minus or plus? The unit?
Negatif.
Negative 100
Negative 100.
degree. That one is the azimuth angle. Okay, next one. Number 2. What is the civil time What is the silver time? When the solar time is 12 noon on 1st September 2015. Okay. Dia tanya silver time, but the solar time is 12 noon. Kat mana tu? What happened to the sun during a solar noon? The sun at the top of your head, right? Which is here, 90 degree, right? Okay. Kalau 90 degree, okay, what is the value of your solar time, your silver time? Berapa tu kat sini? This is 12 o'clock, this is 1 o'clock, this is 2 o'clock silver time. Berapa ni?
1 minit.
Dalam satu ni 1.5 kat sini kan? Okay, this is 1:30. Ni dalam berapa? 1:15, right? Lebih kurang 1:15 PM. This is silver time during solar noon, which is 12 solar time solar time. Okay, which is at the altitude angle berapa masa tu? Matahari dekat 90 degree. Okay, sebab tu saya letak kat tengah tadi then tarik kat sini. Okay. Or you can calculate manually 1 degree, how much the 1 degree, berapa dia punya time boleh calculate manually, or you can what English congak you just try and error here about 1:15 PM. Okay, next one, number 3. What time is the sun set on June solstice? Okay, where is your June solstice? Okay, where is your June solstice? The green color
The green color.
Okay, and the December solstice is the blue color. Okay, why the June solstice is on the top? Kenapa dia duduk kat atas? Kenapa dia tak duduk kat bawah? June solstice tu, why? Why is on the top?
Musim panas.
Okay, June solstice. What happened to the North Hemisphere?
Musim panas.
Musim panas kan? On the North Hemisphere. Okay, saya buka chapter ni. Okay, please remember back you have learned this in geography ke? This one How the 4 season happen? Okay, during March and September, you have this equinox. Equinox is when the sun ray is exactly at the 0 degree latitude. Okay, yang ni betul-betul atas 0 degree, which is musim masa ni panas on the equator So this area we have this equinox. Equinox mean the sunlight is exactly at 0 degree latitude which is happen on March 21st to 22nd and September 22nd to 23rd. Okay, you must imagine this one in 3D this sunlight is actually on the other side of this figure Okay, but what happened on the June? Okay, because the earth rotate a little bit decline, what happened on the June? Okay, tengok sunlight kat sini, you refer to the sunlight. the sun ray is on the top of the hemisphere, which is on the northern hemisphere. So during this time, Amerika, Russia, semua tu is summertime what happened to the Australia, New Zealand semua tu? They will have this winter time on June Okay, and then move to September, you have again the solar incoming is equal for the north hemisphere and south hemisphere because the sun ray on the center for September again winter. What happened to the north hemisphere? Bulan Disember.
Christmas.
North hemisphere dia akan sambut Christmas kan?
Jadi winter.
Australia tak sambut Christmas ke?
Tak.
Australia tak sambut Christmas?
Sambut.
Australia also celebrate
Celebrate
Christmas,
sekali.
but they celebrate Christmas during summertime. Okay? But the north hemisphere, okay, our reference is the north hemisphere. Sebab semua perkataan ni, all these solstice refer to the north hemisphere. They will have this winter time, okay, during Christmas. Okay, that's why when you see this June, so you have this line. The June is on the north, and December is on the south. Saya buka balik tadi sebab tu you refer here the green color is June so this is summertime on the north hemisphere. Okay, sebab tu dia kat atas. December on the south. Do you understand? Faham ke tak faham?
Faham.
This is very important. This is very important to know which one is June solstice and December solstice because in your final exam, there is no colour here. Dia tak ada colour pun sebenarnya. Okay, tapi ni memang nota ni ada colour. But if no colour, only black and white, you must know where is your June solstice and where is your December solstice. Okay, so what is the sunset? The time. What time is the sunset on the June solstice? Sunset adalah matahari terbenam. So this is your June solstice. So sunset is when the sun is at altitude berapa? Sunset?
0.
0 Okay, so 0 here. So the time is 7:25 PM. Okay. What is the sunrise on the December solstice? Okay, this is December solstice. Sunrise here. Matahari baru nak naik. So the altitude is 0 degree, which is 7:14 AM. Okay
Okay.
Easy right?
Easy.
Okay. Any question? Saya dah habis ni. We already finished chapter number 2. Any question?
No, madam.
Okay, make sure you read this chapter also baca ni. Okay, how this 4 season happen. Okay, during winter time we have a longest day, right? Bila dah ada longest day, they have the saving time semua tu kan. Please read this one what is solstice? What is December solstice? Please read What is equinox? Okay.
Okay, madam.
Yang ni semua saya ada letak dalam open learning Okay, any question before we finish?
Not yet.